Welcome to Daily Papers, the podcast where we break down fascinating new research papers into bite-sized, easy-to-understand chats.
Today, we're looking at a paper that tackles a huge challenge for AI: how to make them better reasoners, especially when they need to use outside knowledge to answer a complex question.
Right. We've all played with large language models, or LLMs, like ChatGPT. You can ask them to write a poem or explain a concept, and they do a great job. But they have a limitation. Their knowledge is frozen at the time they were trained. They don't know what happened yesterday, and they don't have deep expertise in every single niche subject.
Exactly. So researchers came up with a clever solution called Retrieval Augmented Generation, or RAG for short. The idea is simple. Before the LLM answers your question, it does a quick search through a database or a set of documents to find relevant information. It's like giving the AI an open book exam.
An open book exam sounds great. It should make the AI way smarter, right?
You'd think so, but there's a catch. Imagine I asked you which Mars rover landed most recently, and for your open book exam, I just handed you a massive, messy stack of 20 different NASA press releases, web articles, and technical documents. The answer is in there somewhere, but it's buried.
I'd be totally lost. The documents might mention lots of rovers, dates, missions. I'd be wading through so much irrelevant text, I might miss the key facts or get confused. The paper calls this the lost in the middle problem.
Precisely. And that's what happens to LLMs with the standard RAG approach. They get a big wall of text and they struggle to piece together the scattered clues. They might even grab an older rover's game like Pathfinder from 1997 instead of the correct answer, which is Perseverance from 2021.
Okay, so just giving the AI a library isn't enough. It needs a librarian, and that's where this paper, Structure-R1, Dynamically Leveraging Structural Knowledge, comes in. They've built a smarter system that acts like an expert research assistant.
That's a perfect analogy. Instead of just dumping raw documents on the LLM, this new framework, Structure-R1, first reads all that messy text and then organizes the key information into a clean, structured format.
What do you mean by a structured format?
Think about our Mars rover question. Structure-R1 would scan the documents and pull out just the names of the rovers and their landing dates. Then it would neatly arrange them into a simple table with two columns: rover name and landing date.
Ah, I see. With a table like that, answering the question, which landed most recently, becomes incredibly easy. You just look down the date column.
Exactly. It could also create timelines for historical questions, or knowledge graphs to show relationships between people and places. The really cool part is that it's dynamic. It doesn't use the same format for every question. It looks at the query and decides on the fly what the best structure would be. Sometimes it even invents a whole new format if the predefined ones aren't a good fit.
That's very clever. So how does it learn to be such a good research assistant? How does it know which structure to create?
This is where the second part of the paper's title comes in: reinforcement learning. In simple terms, it's a training process based on trial and error with rewards.
Like training a puppy?
It's very similar. The AI model, let's call it the student, tries to answer a question. First, its assistant part creates a structure, say a table. Then the student uses that table to find the answer. If the answer is correct, the model gets a reward, like a digital treat. If it's wrong, no treat.
So over thousands and thousands of attempts, it learns that creating clear, accurate tables leads to more treats.
You got it. But they added another really smart layer to this reward system. They call it a self-reward for structural verification. It's a way for the assistant to double-check its own work.
How does that self-check work?
After the assistant makes the table, it performs a test. It asks the student model to answer the question again, but this time it's only allowed to look at the table, not the original messy documents.
Okay, so it's checking if the table is self-contained. Does it have all the information needed with none of the fluff?
Exactly. If the model can still get the right answer using only the table, it means the table is a high-quality, reliable summary of the knowledge. When this happens, the model gets an even bigger reward. This encourages it to not just make any structure, but to make structures that are both correct and complete.
That makes so much sense. It's not just about getting the right answer, but about building a solid, trustworthy foundation of knowledge to get there. So, did it work? What were the results?
The results were pretty spectacular. The researchers took a relatively small 7 billion parameter model and equipped it with their Structure-R1 framework. Then they tested it against much larger models, including some that were over 10 times its size.
And how did the little guy do?
It consistently performed as well as, or in many cases, even better than the giant models. On complex tasks that require piecing together information from multiple sources, the smaller model with a good research assistant was able to outperform the bigger models that were just given a messy stock of books.
Wow, so it proves that brute force, just having a bigger brain, isn't always the answer. Being better organized and more efficient in how you process information can make a huge difference.
That's the key takeaway. This paper shows that the future of AI reasoning isn't just about feeding them more data, but about teaching them how to structure and organize that data intelligently. It's about turning messy information into clear, actionable knowledge.
A fantastic paper that makes AI not just more knowledgeable, but fundamentally better at thinking. That's all the time we have for today.
Thanks for tuning into Daily Papers. We'll see you next time.